Hello, geometry students. Today we're looking at 5.4 day one. Um, Pretty similar to what we've been seeing the last few days, just kind of turning our focus to the other two, excuse me, the other two um, main kind of triangle congruence theorems that we have. So angle side angle would look something like this, where you've got the two congruent angles and sandwiched in the middle is a congruent side. And then angle side would be when there's two angles in a row that are going to be congruent, followed by a congruent side after them. Remember, they're named kind of how they go around the triangle. Your first couple problems today are going to be where you're just filling in the proofs. So they're giving you that proof mostly filled in, and you're just filling in the pieces that are blank. So kind of getting used to seeing these two congruence theorems put to use. You notice the first blank we have here is that reason number 3. So they're telling us PQR is congruent to STR. We just have to say why. So PQR right here is congruent to STR, and why is that? Well, if you notice in the given statements before that, they're mentioning that both those are right angles. So then the reason, and the way that this is worded on Alex as well, is that all right angles are congruent. So if you know you've got a couple right angles, they're going to be congruent because all right angles are congruent. The next blank that we're looking at is QR is congruent to something else. And it's actually, if we look in the reason column, it's actually the given statement. So it tells you right here what QR is congruent to. So that's going to be TR. Okay, so right now, if we continue to mark this on our diagram, we now have QR congruent to TR, those two lines, and then PQR is or PRQ, excuse me, is congruent to some other angle. And the reason they're giving us is because vertical angle property. Well, where are vertical angles? If we go and look at that diagram, those vertical angles are those kissing angles. They're the ones that face each other on opposite sides of a vertice. And you're looking at those two spots, naming that second angle PRQ. Remember, we got to try and keep that in the same order. So P lines up with S, and then R, and then T. So remember, we have to name those angles with their corresponding parts. So angle SRT would be the angle that PRQ is congruent to. Now that we've got that information, and we have it marked on here so we can see it, we have to go ahead and state, okay, now that we know all that, which of those congruence theorems are we able to use in saying that these two triangles are congruent? We have an angle, we have a side sandwiched in the middle, and we have an angle. So the three congruent pieces line up for the angle side angle theorem, and that would be completing that proof. Now, there's going to be a couple full proofs that you're doing here today. The first of which are going to be similar to that problem we just saw, where you're probably getting a vertical angle in there, or maybe you have a shared side where you talk about the reflexive property, whatever. So those are kind of the first types of problems that you're going to see with statements and reasons. So as we start to fill this out, and again on Alex, you've got the send to proof, and you click on the reason. So first thing we always want to do, list your givens. So DF congruent to HF. And that is that first statement. So that first reason is given. And then you have two pieces of given information. Next one being that angle DEF is congruent to angle HGF. And that is also given. So let's go ahead and mark that information. So DF is congruent to HF right there. DEF is congruent to HGF right there. Okay. Oh, sorry. HGF right there, okay? And then right now, you're kind of left with what do we have to add in here to be able to get to this statement that the triangles are congruent? Well, again, there's two options like we talked about last week. You can look for something that's going to create one of those congruence theorems, or you can just take whatever that diagram is giving you, which is the easier way to do it, and then see which one of those congruence theorems shows up. So what is this diagram giving us? Well, they've got two vertical angles. We know every time those vertical angles are going to be congruent. So right now we can say that GFH, so let's name that one angle GFH is congruent, and then we've got to name this in the corresponding manner. So EFD and that is because they are vertical angles, and that would be the reason on Alex as well. So now that we've got all that information, let's look at, do we have one of these congruence theorems? Well, we have one set of vertical angles, we have one set of congruent angles, we have a second set of congruent angles, and then that third piece of congruence is the side after the two angles. And so we can go ahead and say that triangle DEF is congruent to triangle HGF by angle, angle, side. We've got the two congruent angles and then the side at the end. Okay, now we're going to get kind of a new type of visual that we're going to start seeing, where we've got some overlap triangles. Now there's a lot of stuff going on here, but they want you to focus on these couple that have been separated. And this is going to come up in a proof in our last group of problems. So HIL is the first one that we're going to be talking about. And then JIK is that second triangle. So when we can draw that down here, when we can actually separate them. Now I know your homework is on Alex, but redrawing these two triangles separated apart like they did here in part A is really going to help you be able to visualize and see what's going on. So for your Alex homework, when you're doing these proofs, especially like the last couple problems where it's proofs of these diagrams, have some scratch paper, draw these things separated out and label their sides. So they have us practicing that. So in blue, that first triangle, they're kind of giving us a hint with the numbered vertices. So the vertice at 5, that angle at 5 is your H. The 9 is down at L. And then that third angle, which they don't label, but is over there at angle 7, is at the I. So draw these things split up and label them. Then you can use that to kind of make your markings, and you can see it a lot more clearly with these triangles separated. Even when they're kind of turned around or flipped like they are here, at least you can see and mark things up with them ripped apart. They're separated. So again, angle 8 is K. 3 is down there at J. And then that one that's not marked is over at I. Now, the question they're asking you here for part B, you're only going to pick one of these. Don't try to fill all three of them in. It's either they have a common side, or they have a common angle, or they don't share any common sides or angles at all. Now, this isn't saying which ones are congruent. They're saying which ones are shared, common side or common angle. Well, if we look, we get a little confused with these things because we might want to say, oh, the green and the blue overlap in all these parts here, but none of those are full sides to a triangle, right? They don't share common sides of a triangle. What they do share is they both completely have this angle as a part of their triangle, that angle 7. And I'm pretty sure on Alex, so when we go ahead and say, okay, they don't have a common side, but these two do have a common angle, when you drop this down, I'm about 99% positive all those angles are going to be labeled as the numbers in the diagram for this sake, so that they're easier to identify. So they have a common angle, and in this case, it's angle 7. Okay, so these couple problems that you're going to have on your homework are just getting you prepared to set up for these proofs. So now on these proofs, SVR and SUT is what we need to prove congruent. So let's do what we just did. SVR. Let's kind of tear these two things apart. Okay, so there's SVR, and what I'm actually going to do here, whoops, is just clone that and move it down so we can easily see what we're talking about. So we've got S, V, and R. I strongly suggest that during your homework here, you're using some scratch paper to split these things up. And then S, U, T is the next one. And again, let's see if I can do that again. Clone that. Sweet. Okay, and then we'll move that over here. And so those are the couple that we're looking at. Okay, so those are our two triangles within that diagram that we're talking about. Okay, so before we start marking stuff up, let's just make our two-column proof. Let's set that up. So we've got statements and we've got reasons. Well, first of all, let's get those givens written down. Measure of angle 5 is equal to the measure of angle 6. So notice they're not giving us congruent statements here. They're saying things are equal. That's going to change what we're going to do for those first couple statements after the givens. So that one was given, and then what else was given was the fact that SV is equal to SU. So we've got our given statements down. Now remember, from all of our work with proofs before this stuff, we can't mark anything as congruent right now because nothing is technically congruent. They're labeled as equal. But when they're equal, that's the definition of congruence. So we can go right ahead and state in number 3 that angle 5 is now congruent to angle 6, and that segment SV is congruent to SU. Make sure you're putting that line above them. The reason for both of these on Alex is going to be the definition of congruence. Because whenever something is, two things are equal, they're congruent, or if they're congruent, then their measures are equal. Either way, those are definition of congruence. Okay, so right now we've got these two things being congruent then. 5 is congruent to 6, which in our diagrams would be these angles. See how much easier it is to see with those separated triangles. And then SV to SU. So SV, which is right here, to SU, which is right here. So right now we can see we've got an angle, we've got a side, and then we've got to state one more thing before we're able to go ahead and say those triangles are congruent. That's where this thing comes in. There's going to be some shared, they don't have a vertical angle like this, they don't have a shared side with reflexive property, or I shouldn't say that. They don't have vertical angle set up like this. They're going to have some shared side or angle that you practiced in these problems that you're going to be looking for in these diagrams. So again, much like this, it's actually the exact same picture, just flipped. They don't have a shared side, but they do both fully have this angle in their triangles. So that angle is going to be congruent to itself, and you can just say on the Alex proof, you can just say angle S. So angle S is congruent to itself because of the reflexive property, and then to finish, we are going to be able to say angle, side, angle. So those two triangles, SVR, triangle SVR is congruent to triangle SUT, I think. Yep, SUT by angle, side, angle. Okay, I've only got like 10 seconds left before this video stops. So that's all your homework examples. Good luck with your homework today. Keep working hard. We got a couple more days of these theorems, and then we're going to start prepping for a test. Have a great day.